Hey everyone, hope you're good. It's another video on Graviflyer, thoughts and observations. This is a follow-up to video number 2, where I mentioned syncing oscillators together in order to drive coils for your high voltage plates or your Tesla, or a sine wave for your piezo element to create the ultrasound. Here's a modular synth I built quite a few years ago. And up here on the breadboard is the test circuit that I'm working on right now to go drive those coils and such. I'll be putting out a schematic on that shortly. Unfortunately, it does use a bipolar power supply, so that's going to be a little bit of a challenge to overcome. What I wanted to show you though was a visual representation of actually the hard syncing of two oscillators. So here's our oscilloscope, good old Mordax data. Let's just use this system since it's closer to the oscilloscope. I'm going to take an output from the tip-top audio, Z3000. Let's do the sine wave. And yeah, it's set to 8 Hertz right now. Let's just pretend that that's driving our piezo element at 32 kilohertz or something, you know, the ultrasonic there. All right, so let's just go into input 1. All right, and there's our sine wave on the green trace. Okay, so let's go ahead and take another output from, where are we? Another tip-top oscillator. And we'll do another sine wave just for representation, a little easier. You know, we're going to be using square waves to drive those coils and, well, or the MOSFET, which is going to help us drive the coil. We're going to go into number 2, and you can see that they're both completely, you know, out of sync with each other. Okay, and of course they're at slightly different frequencies. So what we're interested in is this guy right here, sync input. So what we want to do is sync oscillator 2 down to our lower left from oscillator 1. So let's go ahead and take this guy, magic saw wave, which is also very useful. We're going to go into the sync input. Where are we? There we go. Oscillator 2. Right. Let's go back to our oscilloscope. Check it out. They're super close. All right, so now you can actually take the frequency of oscillator 2 and start moving it back and forth. See that? So you can take it in and out of phase with oscillator 1. We're very close. Like that. Okay. Take the sync out, and they're completely, right, not related to each other any longer. We'll put it back in. And we're back. All right, so we've synced the two oscillators. Now let's actually get them to track frequency-wise together. Okay, so let's go over here to, we'll just need one control, right? So just one knob to take care of it. It's the mutable instruments shades. We'll take number 1. It's going to be our red knob. All right, and we're going to go ahead and put it into here, FM2. And in fact, what we should do is, let's molt this signal first. All right, so we're just making copies of that knob output. Take that, go right into FM2. Its input attenuator set to about noon. It's not super critical for this one. I'm just going to go ahead and copy that signal again and take it to oscillator 2. Again, into the FM2 input. All right, so now it's like, oh baby. All right, so we're all the way down because what we've done is we've given a full negative offset because the switch is set to bipolar. So if we move this up to the center position, let's come back. And there we are. They're in sync. And now you can move two frequencies of both oscillators together with one knob. Right? So it kind of gives you an example of syncing two oscillators and then having them both track the same frequency. So you can take all the oscillators, put them exactly in phase with each other, or take them slightly out of phase with each other, and then go ahead and drive them all together with one voltage source. Right. Okay. I think that kind of gives a clear visual representation of what I'm getting at by syncing oscillators together and syncing multiple functions on the Graviflyer together by having a hard sync input onto these, into these actual oscillators. So this oscillator is based on a sawtooth core, right, which will have a FET over the cap, and so that you can then send it a trigger and dump the charge on the cap, and thus get yourself a sync input. Okay, and then from there you're driving a MOSFET, which is then driving the coil and then into a voltage multiplier. All right, so there's just a quick visual for you guys. Thanks for watching. Take care.